Hi everyone, this is Professor Oaks, and this video is about dividing polynomials. So let's first talk about the long division of polynomials. So here we go. Here is the division algorithm. So if p of x and d of x are polynomials with d of x not equal to 0, then there exists unique polynomials q of x and r of x, where r of x is either 0 or of degree less than the degree of d of x, such that p of x divided by d of x is equal to q of x plus r of x divided by d of x. So the p of x is called the dividend, the d of x is the divisor, the q of x is the quotient, and the r of x is the remainder. So you can see here that p of x over d of x equals q of x plus r of x over d of x is equivalent to this statement over here, p of x is equal to d of x times q of x plus r of x, if we just clear the fraction on this equation by multiplying through by d of x. Alright, so there is a procedure here for the long division of polynomials, but let's do this through demonstration of an example here. So, if we want to divide 2x to the third plus 7x squared plus 2x plus 9 by 2x plus 3 and write the solution in quotient plus remainder over divisor form, then here's what we would need to do. So step 1 is to arrange the dividend and the divisor in descending order and insert 0 for missing powers. So remember, this numerator here is what we call the dividend, and the denominator is the divisor. So these are already in descending order, with the exponents going from highest to lowest in all of them in place. 3, 2, 1, 0, x to the first 1, x to 0. Alright, so now the next step is to divide the first term of the dividend by the first term of the divisor, and then write this quotient on the line above the dividend. So what we do is we divide the first term of the dividend by the first term of the divisor. So that would be 2x to the third over 2x, and that gives us x to the second. So we write the x to the second above the dividend, but I'm going to make sure that I line up the x squared with the x squared, just so that this looks nice, and then when I reach the end that I know that I'm done. Then I'm going to multiply this quotient times the divisor over here. So x squared times 2x plus 3 is equal to 2x to the third plus 3x squared. And that's where I get this from right here. Then I'm going to subtract. So 2x to the third minus 2x to the third, so remember, you're going to subtract here, is 0. 7x squared minus 3x squared is 4x squared. Then I can bring down the 2x and the 9, because this is really like plus 0 plus 0. Alright. So then I repeat the process. So right now, at this step right here, it's like I have a new problem of 2x plus 3 goes into 4x x squared plus 2x plus 9, and I repeat the process for 4x squared and 2x, alright? So 4x squared divided by 2x is 2x, and so that's where this plus 2x comes from, and I line that x above the x's. Then I repeat the process again, this quotient here times the divisor, so 2x times 2x plus 3 is 4x squared plus 6x, and that's where this comes from. Then I subtract, so 4x squared minus 4x squared, 0. 2x minus 6x is negative 4x. So make sure again that you're subtracting here. 2 minus 6 is negative 4. And then this is, of course, like plus 0. So I end up with negative 4x plus 9. Then it's like I'm starting over again with this line right here. Alright, so I have 2x plus 3 goes into negative 4x plus 9. So I have the negative 4x in the 2x. So negative 4x over 2x, that's negative 2. So that's where this negative 2 comes from. Then I take that quotient times the divisor, negative 2 times 2x plus 3. That is negative 4x minus 6, so that's where this comes from. Then I subtract. So negative 4 minus negative 4 is 0, so that's negative 4x minus negative 4x is 0. And 9 minus negative 6 is a positive 15. And so this is the quotient here. So if I want to write this in quotient plus remainder over divisor form, now this is the remainder here. All right, now again, one thing that I do want to make sure that you're clear on is the fact that I knew for sure that I was done dividing because I have reached the end of the dividend here, for one thing. But the second thing is that this is actually degree 0, and this divisor is of degree 1, and when this remainder here, right, or whatever you get from each of these divisions, has a degree that's less than the degree of the divisor, then you know that you are done. All right. So in quotient plus remainder over divisor form, the quotient is x squared plus 2x minus 2 plus remainder of 15 over the divisor of 2x plus 3. There you go. So that's one way to go about this problem here. So let's try this again. Divide 2x to the 4th minus 9x to the 3rd plus 21x squared minus 26x plus 12 by 2x minus 3. So this is the dividend. This is the divisor. All right, so first we'll start with making sure that the dividend and divisor are all in descending order. So I look at the exponents and they are in descending order. 4, 3, 2, 1, 0. Divisor 1, then 0. So I start with the first terms here, the leading terms here of the dividend and the divisor, and I divide. So 2x to the 4th over 2x. And by the way, this one isn't even really lined up the way that I would again, recommend that you line this up. It's just that happens to be how it shifted when it printed here, but you can see that I will even go ahead and move this over so that you can follow along a little bit easier with me. So we have x to the third minus 3x squared plus 6x minus 4. All right, so 2x to the fourth divided by 2x is x to the third, so that's where this comes from. So then we take the quotient we just got, x to the third, and then multiply by the divisor, so times 2x minus 3. That gives us 2x to the fourth minus 3x to the third. So that's where this comes from. And then we subtract 2 minus 2, 0. Then negative 9 minus negative 3 is negative 6. So we have negative 6x to the third. And then, of course, you bring everything down because it's plus 0. Now, we start over again. And we look at the negative 6x to the third divided by the 2x. That gives us negative 3x squared, which is where this came from. Then negative 3x squared times the divisor of 2x minus 3 is negative 6x to the third plus 9x squared. And that's where this came from. And then we subtract negative 6 minus negative 6 is 0. 21 minus 9 is 12. So we have 12x squared. And then, of course, we bring these down because this is plus 0. So minus 26x plus 12. Then we do this again. 12x squared over 2x. And we divide and get, let's see, 6x, which is where this comes from. Then 6x times 2x minus 3 is 12x squared minus 18x. So that's where this comes from, and we subtract 12 minus 12, 0. Negative 26 minus negative 18 is negative 8. And then, of course, we bring down the 12 because it's plus 0 here. Then negative 8x divided by 2x. So as long as we can divide still, we have to keep on going. So that will be negative 4, which is where this came from. The negative 4 times 2x minus 3 is negative 8x plus 12, which is where this came from. So negative 8 minus negative 8 is 0, and 12 minus 12, 0. So this is the quotient, and this is the remainder. So a remainder of 0 actually means that 2x minus 3 goes into 2x to the fourth minus 9x to the third plus 21x squared minus 26x plus 12 evenly. All right, since the remainder was 0. So if I want the quotient plus the remainder, all right, over the divisor form, then that will just be x to the third minus 3x squared plus 6x minus 4 plus 0 over 2x minus 3, but 0 divided by 2x minus 3 will just give us x to the third minus 3x squared plus 6x minus 4. Now again, we're going by the fact that we don't want this divisor to be equal to 0, but that's okay for our purposes, since this was how the division algorithm was defined. All right, so let's try another example here. So x to the third minus 12x squared minus 42 divided by x squared minus 2x plus 1. You notice that the dividend and the divisor, So here's the dividend and the divisor are both in descending order, 3, 2, but the dividend is missing an x to the first power, so I need it to write in 0x to the first power. Alright, so try to make sure that you don't forget that important step. Otherwise, this is very similar. You start with the leading terms, x to the third divided by x squared is x, and I'll line the x above the x here. So even though I had 0 x's to begin with, there is an x in the final quotient here, the final answer here. Alright, so then I take the x times the divisor, x squared minus 2x plus 1, that's x to the third minus 2x squared plus x. Then I subtract x to the third minus x to the third, 0, negative 12x squared minus a negative 2x squared is negative 10x squared. 0 minus x is negative x, and then this is, of course, plus 0, so I bring down the negative 42. Then I start over. Alright, so here we go. Negative 10x squared divided by x squared, that's negative 10. So that's where the negative 10 here came from. The negative 10 times the divisor, x squared minus 2x plus 1. That gives me negative 10x squared plus 20x minus 10, where this is from. Then I subtract negative 10 minus negative 10, 0. Negative 1 minus 20 is negative 21, and negative 42 minus a negative 10 is negative 32. Then I look here, and I see this is of degree 1, and this, the divisor, is of degree 2, so that means I'm done. Or another indication to me would have been that I had reached the end of my dividend up here. Alright, so there we go. So I know that this is going to be the quotient, and this is the remainder. So if I want this written in quotient q of x plus remainder r of x over divisor d of x form. Right now, look at that. Look at what the abbreviation for quotient and remainder and divisor did for me now. I didn't have to write out the entire word, so this is where I will begin to try to use a little bit of that notation so that we don't have to write that out every time from now on. But this will end up being x minus 10 plus the negative 21x minus 32 over x squared minus 2x plus 1. Alright, so I really hope that you enjoyed that example because it's time for another one. So let's divide x to the third minus 2x squared minus 4 by x minus 3. So again, here is the dividend, and here is the divisor. So we'll start by making sure that we have all of the powers of x in descending order in the dividend and the divisor. So I need it to write in the 0x to the first again. So let's start with the leading terms and divide these. So x to the third divided by x is x squared. So that's where this came from. Then x squared times the divisor, x minus 3, gives us x to the third minus 3x squared. That's where this comes from, but I have to subtract. So x to the third minus x to the third, 0. Negative 2x squared minus a negative 3x squared is a positive, let's see, 1x squared. Then this is plus 0, so I can bring down the negative 4. Alright, so now I look at the first terms again. So I have x squared divided by x, so that's x, so that's where this comes from. I multiply that quotient times the divisor of x minus 3. That gives me x squared minus 3x. So that's where this comes from, but then I need to actually subtract. So x squared minus x squared 0. 0 minus a negative 3x is a positive 3x, and that plus 0. So I can bring down that minus 4 like this. Then I look at the first terms again, and I have 3x divided by x, which is 3, so that's where this comes from, and then 3 times the divisor of x minus 3 gives me 3x minus 9. That's where this comes from by subtract, so 3 minus 3 is 0, negative 4 minus negative 9 is a positive 5, and then I see that I'm done, and here is the quotient, and here is the remainder. Whew. Yeah, I will tell you that as a reminder, for those of you who've been following along, I'm working from my kitchen table right now, and it is quite toasty in the kitchen right now. So there's something in the oven. So let's see. I hope it's like some taquitos or some quesadillas, because I'm pretty hungry since I haven't been able to get any chicken shack or anything like that in the last few days here. But in any case, if we wanted to write this in the quotient, or q of x plus remainder r of x over divisor d of x form, then the q of x would be x squared plus x plus 3 plus the remainder 5 over the divisor x minus 3. There you go. So that is the form that was requested for this example here. So now let's try another example here. All right, so you can see that I got this here graphic from that math website there, but you know, that was to help me type this out here, but of course that's not really part of the problem, so I'm going to wipe that out there. So the first thing in this problem is to divide x to the 6th plus 2x to the 5th plus 5x to the 3rd plus 4x squared plus 6 by x to the 3rd plus 2. So this is going to be the dividend, and this is going to be the divisor, and I need to write these in descending order, which these actually were, but the dividend was missing 2 of the powers of x to the 4th and x to the 1st, so I wrote those in. You could actually write this divisor as x to the 3rd plus 0x squared plus 0x plus 2 if you would like, but that part isn't as important as making sure that the dividend has all of the 0 terms actually written in here. So again, there's also, even though like I said, I had the math website help me type out this graphic here, they didn't line all of these terms up the way that I normally would, just to make sure that my work is checked. So I'm going to line them up for us here. So x to the 3rd plus 2x squared plus 3. All right, so let's start by dividing the leading terms, the first terms here. So x to the 6th divided by x to the 3rd is equal to x to the 3rd. That's where this comes from. Then x to the 3rd times x to the 3rd plus 2 is x to the 6th plus 2x to the 3rd. So that's where this comes from, and then I subtract. So x to the 6 minus x to the 6, 0. 2x to the 5th minus 0, so this is plus 0, plus 0, plus 0, plus 0, plus 0, okay, is 2x to the 5th plus 0, then 5x to the 3rd minus 2x to the 3rd is 3x to the 3rd, then of course these are all plus 0, so I can bring all of the rest of the terms down. All right. Now, let's look at the leading terms again. 2x to the 5th over x to the 3rd. That gives me 2x squared, which is how I get this. Then 2x squared times the divisor of 3, or x to the 3rd plus 2 is 2x to the 5th plus 4x squared. So here I can see that here. All right. So I will write in all the zeros just so that you can see this easier, hopefully. But 2 minus 2, 0. 3 minus 0, 3. So 3x to the 3rd plus 0, and then 6 minus, 0, 6. So then I look at the leading terms again. 3x to the 3rd over x to the 3rd, that's 3. That's where this comes from. So then 3 times the divisor of x to the 3rd plus 2 is 3x to the 3rd plus 6. So here is this part right here. Then 3 minus 3, 0. And, well, I wrote that in the wrong spot. I did not write that in the wrong spot. I thought that I did because of how I was looking at it here. So 6 minus 6, 0. So this is the remainder here. And here is the quotient. And remember that when the remainder is 0, that means that the x to the 3rd plus 2 goes into x to the 6 plus 2x to the 5th plus 5x to the 3rd plus 4x squared plus 6 evenly. So in quotient of x, q of x plus remainder r of x over divisor d of x form, we have, let's see, what do we have? We have x to the 3rd plus 2x squared plus 3 plus 0 over x to the 3rd plus 2, or just x to the 3rd plus 2x squared plus 3. All right, so now let's look at another example here. Explain where the negative 31x in step number 9 came from. So step number 9 was right here. So if I look at where the negative 31x would have come from, well, that would have been from the, all right, so that would have been from negative 31x squared divided by x. And that's negative 31x. So that's all that this question was asking for, is just where did one specific part of the long division come from. All right, so let's try some other types of problems here. So express the results now in q of x plus r of x over d of x, and in p of x equals d of x times q of x plus r of x forms. All right. So here we go. First one, we have x minus 4 goes into 3x squared minus 7x minus 26. So we have 3x squared over x, that's 3x. 3x times x minus 4 will be 3x squared minus 12x. So 3x squared minus 12x. I'll subtract. So 3 minus 3, 0. Negative 7 minus a negative 12 will be a positive 5. So 5x minus 26. Then 5x divided by x is 5, so plus 5. And 5 times x minus 4 will be 5x minus 20, so 5x minus 20. And then I subtract 5 minus 5, 0. Negative 26 minus negative 20 is a negative 6. So this is the, all right, so this is the quotient. and this is the remainder, and this is the dividend or the polynomial that I'm dividing, and here is the divisor, what I'm dividing by. So in the first form, I have that 3x squared minus 7x minus 26 over x minus 4 is equal to 3x plus 5 plus a negative 6 over x minus 4. That's the first form that we asked for. And the second form is 3x squared minus 7x minus 26 is equal to the x minus 4 times 3x plus 5 minus 6. All right, so now let's look at this next example. So I have 3x minus 2, and I need to write in the 0x squared in the dividend here. So let's start 9x to the third, divide it by 3x, that is 3x squared, so I'll line that up above the x squared. Then 3x squared times 3x minus 2 is 9x to the third minus 6x squared. So 9x to the third minus 6x squared. Then I'll subtract 9 minus 9, 0. 0 minus a negative 6 is a positive 6, so 6x squared plus 11x minus 2. Then divide again, 6x squared divided by 3x, it's 3x, so plus 3x. Then 3x times 3x minus 2. Ooh, this problem is making me hungry, I'll tell you that much right now. Let's see. So now we have 3x times 3x minus 2, that's 9x squared minus 6x, so we have 9x. Oh, sorry, that can't be right. This is definitely, now that I see it, you see I see 9 here. 6 divided by 3 is definitely not 3, it's 2. There we go. And you guess how I realized that? I double checked my work because this should zero out. So there we go. I told you I was hungry. If I weren't so hungry, this wouldn't have been a problem, right? So just remember that, everyone. All right, this is what hunger does to you. All right, so 6x squared minus 4x. So we have 6x squared minus 4x. All right, so now let's subtract 6x squared minus 6x squared is actually 0. 11x minus negative 4x is, there we go, it is 15x minus 2. And then we divide again, 15x by 3x. All right, this time I'll concentrate 15 divided by 3 is 5. All right, so plus 5. Oof, those chocolate chip cookies are getting to me. All right, so then 5 times the divisor of 3x minus 2 is 15x minus 10. So we have 15x minus 10. Then we subtract 15 minus 15, 0. Negative 2 minus negative 10 is a positive 8. So this is the dividend, p of x. This is the divisor, d of x. This is the quotient, q of x. This is the remainder, r of x. So we can rewrite this in, right? So 9x to the third plus 11x minus 2 over 3x minus 2 equals the quotient, 3x squared plus 2x plus 5 plus the remainder 8 over the divisor 3x minus 2 form, or we can write it in the form of p of x, which is the dividend 9x to the third plus 11x minus 2 is equal to the divisor 3x minus 2 times the quotient 3x squared plus 2x plus 5 plus the remainder form plus 8. So these are the two ways that we were asked to write this problem here. So these two are equivalent statements, and these two are equivalent statements. All right, so now let's look at an example of synthetic division and the remainder theorem here. So you can see the synthetic division here. Now, the one thing that I do want you to remember about synthetic division is that this is only to divide a polynomial by a binomial of the form x minus c. So if you look at all of the other examples that we've had so far, this was in example 1 not x minus c, it was 2x, all right? The example 2, this was not x minus c, it was 2x. This was not x minus c, there was an x squared. This was in x minus c form, so we could have actually did example 4 using synthetic division. But example 5, this was not x minus c, it was x to the third. And then example 6, it was x minus c, so we could have used synthetic division. And example 7a, it was x minus c, so we could have used synthetic division. But in example 7b, it was 3x, so we could not have used synthetic division. So just remember that synthetic division is to be used when we're dividing by a binomial of the form x minus c. So here is an example here. If we want to work on this problem here of 3x to the third plus 4x squared minus 3x plus 2 divided by x minus 2, or x minus 2 goes into 3x to the third plus 4x squared minus 3x plus 2. So you can see that this is in the form x minus c. So we write the 2 here, and then all of the coefficients of the dividend here, so 3, 4, negative 3, 2. Then you'll bring the first coefficient down here. Then multiply 2 times 3, 6. Then add 4 plus 6, 10. Then multiply 2 times 10, 20. Then add negative 3 plus 20, 17. Multiply 2 times 17 is 34. Add 2 plus 34 is 36. So then this number is always the remainder. And then you can see that these other numbers, the 3, the 10, and the 17, make up the coefficients of the quotient. All right, so this is a different way, in a sense, a shortcut way of polynomial long division, but only when you're dividing by a binomial of the form x minus c, or x minus some number. So let's use synthetic division to perform each division and find the quotient and remainder, and then also find each functional value. All right, so we have x minus c. All right, so and we should write the dividend in descending order. So x squared minus 2x minus 15. All right, so now remember that c is going to be negative 3 because it's the opposite sign of what's here. So that was x plus 3, so c is negative 3. All right, so here is my c value, negative 3. Then I want the coefficients of the dividend in descending order. So 1, negative 2, negative 15. And then bring down the first coefficient, 1. then multiply. So that's multiply. Negative 3 times 1 is negative 3. Then I add. Negative 2 plus negative 3 is negative 5. And then I multiply. Negative 3 times negative 5 is 15. Then I add. Negative 15 plus 15, 0. So the remainder is 0. So that means that x plus 3 goes evenly into x squared minus 15 minus 2x. So the quotient then will just be, remember these are the coefficients of the quotient, so it will be 1x minus 5 or just x minus 5. All right, now if I want to find the functional value, here is a trick. All right, so if you have p of negative 3, it would normally be negative 3 squared minus 15 minus 2 times negative 3, right? So 9 minus 15 plus 6, that would be 0. Well, guess what? P of C will always be the remainder. And I already knew the remainder was 0. All right, so that's another shortcut here. All right, so now here is the, oh, by the way, that was the other part here. That was actually the remainder theorem. If a polynomial p of x is divided by x minus c, the remainder is p of c. I was looking for where that was stated in a box, but I didn't see it, but that's the shortcut here. So now let's try this again. We have the dividend 4x to the third plus 5x squared plus 0x minus 1. And then we have the x minus c here, but this is c will be negative 2 in this case, a negative number again. So we have negative 2. Then the coefficients of the dividend, 4, 5, 0, negative 1. Bring down the first one, so we bring down the 4. Then we multiply. Negative 2 times 4 is negative 8. Add 5 minus 8, negative 3. Multiply. Negative 2 times negative 3 is 6. Add 0 plus 6, 6. Multiply. Negative 2 times 6 is negative 12. Add to get negative 13. So this is the remainder. So that means the quotient then will be, remember these are the coefficients for the quotient, so 4x squared minus 3x plus 6. And then that means p of negative 2 should be negative 13, but we can check that. All right, so p of negative 2 is 4 times negative 2 to the third plus 5 times negative 2 squared minus 1. So 4 times negative 8 plus 5 times 4 minus 1. So that is negative 32 plus 20 minus 1. Negative 12 minus 1 is indeed negative 13. So p of c, again, will be the remainder. So I hope that you enjoyed that example. And now it's time for another great example here. So it's time for the factor theorem. So C is a 0 of p if and only if x minus c is a factor of p of x. So use the given information to factor p of x completely. So let f of x be negative 2x to the third minus x squared plus 4x plus 3, and f of negative 1 equals 0. So that means that f of c will be 0. Well, that means that All right, since the remainder is 0, that means x minus c goes evenly into the negative 2x cubed minus x squared plus 4x plus 3. All right, so let's see what happens here. We have negative 1, then all of the coefficients of f of x, so negative 2, negative 1, 4, 3, will bring down the negative 2. Negative 1 times negative 2 is 2. Negative 1 plus 2 of 1. Then negative 1 times 1 is negative 1. 4 plus negative 1 is 3. Negative 1 times 3 is negative 3. Negative 3 plus 3 is 0. So I know that the quotient then is negative 2x squared plus x plus 3. Then I can go ahead and try to factor this if I would like to. So negative 2x and x. All right. So then I might want to go ahead and just remember that I want the first term to be negative, middle term positive, last term positive. So let's go with a 1 and a 3. So plus and minus. All right, you can check that. All right, so let's check. We have negative 2x squared plus 2x plus 3x minus 3. Well, that did not work. All right, so let's try again. Negative 2x and x. Again, I think that you know what needs to happen now then, right? It should be negative 2x plus 3 times x plus 1. So let's check this one. So that will be negative 2x squared minus 2x plus 3x plus 3. So that gives us negative 2x squared plus x plus 3. So again, if you're not sure about your factoring skills, always make sure that you check here. So then, if I want to factor p of x completely, then remember, the p of x was f of x in this case. So we had p of x is negative 2x to the third minus x squared plus 4x plus 3. And we knew one of the factors was x minus c, or x minus a negative 1. So that will be x plus 1. And then the other factors were the negative 2x plus 3 and the x plus 1. So I can also write this as just x plus 1 squared times negative 2x plus 3. And there I factor this cubic polynomial completely. All right, so let's try again here. We have, whoops, unbelievable. We have f of x is equal to 3x squared minus 7x plus 4, and f of 1 is equal to 0. So f of c is equal to 0. So that means that x minus c goes evenly into f of x, and x minus c in this case is x minus 1. All right, so we know that's one of the factors. In other words, x minus 1 is a factor of f of x in this case. All right, so now let's do the same thing here. C was 1. Then we need the coefficients here. We have the 3, the negative 7, and the 4. Let's bring down the 3. 1 times 3, 3. Then add negative 7 plus 3 is negative 4. 1 times negative 4 is negative 4. 4 minus 4 is 0. This is the remainder here, so that means that the quotient is going to be 3x minus 4. So then we can go ahead and write p of x as, that would be in this case 3x squared minus 7x plus 4 as 3x minus 4 times the x minus 1. So hopefully that all makes some sense here. Now, here's another great example. Let f of x equals 7x to the third minus 5x squared minus 8x and f of 0 equals 0. So this remainder of 0 means f of c equals 0 means, again, that x minus c is a factor of f of x, but here c was 0, so x minus 0, or just x, is a factor of f of x. Now, hopefully, that wasn't painfully unobvious, because we have an x right here in every term of f of x. But if we did not know that, then we could start by going ahead and let me focus this for you again, just to make sure that okay, there we go. I don't know what is going on. Sometimes I feel like the buttons are working and sometimes they're not, and you never know here, right? Alright, so there's your life going in and out of focus, and here we are back. Alright, so now let's have the coefficients of f of x in descending order. So 7, negative 5, negative 8, 0. Let's bring down the 7. 7 times 0 is 0. So negative 5 plus 0, negative 5. 0 times negative 5 is 0. Negative 8 plus 0 is negative 8. And 0 times negative 8 is 0. And 0 plus 0 is 0. So I know that this is the remainder, but then the quotient is actually just 7x squared minus 5x minus 8. And then I can factor this, so we have 7x, and we have x. And hopefully you can see that unlike the example 3a, where if you tried a different guess, you would get something that did factor, that in this case there is no factorization that works here. So that would be it here. So that means that p of x will be equal to, alright, so the first factor is just the x, and then the second factor is the 7x squared minus 5x minus 8. Alright, so now here is the maximum number of zeros theorem. So if f is a polynomial function of degree n, then f cannot have more than n zeros, not necessarily all different. So let's find a polynomial function f that has degree 3 and zeros of negative 2, 0, and 4. So if these are the zeros at c equals negative 2, c equals 0, and c equals 4, then the f of x will be x minus a negative 2, x minus 0, and x minus 4. Remember the x minus c format that we've been saying is, if these are the zeros, x minus c's are the factors of f of x. So we have x plus 2 times x minus 4 distribute the x, so x squared plus 2x times x minus 4. Then distribute again, so we have x to the third minus 4x squared plus 2x squared minus 8x. And combine like terms to get x to the third minus 2x squared minus 8x. What a time to be alive. I really hope that you enjoyed this example here. So this is, again, of degree 3. We see it right here. So this is what we were being asked for. So now let's find a polynomial function f that has degree 4 and zeros of negative 2, 3 multiplicity 3, and 1 multiplicity 1. So that's saying that the zeros are negative 2, 3 multiplicity 3, so 3, 3, 3, and 1 multiplicity 1. But that means that this had 5 zeros, 1, 2, 3, 4, 5, but it's of degree 4, so this is not possible. So the maximum number of zeros for a degree 4 polynomial is 4, so this is not possible, meaning it's not possible for a degree 4 polynomial or a 4th degree polynomial to have 5 zeros. All right, now let's find a polynomial function f that has degree 3 and has zeros of negative 1, 2, 3, and f of negative 2 is equal to 4. All right, this one is a little bit harder because we have f of 2, f of negative 2 must be 4. All right, so here we have c is equal to negative 1, c is equal to 2, c is equal to 3. So what are we going to do about this f of negative 2 is equal to 4? Well, here we go. F of x will be some constant a times x minus a negative 1, and then x minus the 2 and x minus the 3. So that will be a times x plus 1, x minus 2, x minus 3. And then when I substitute in the negative 2, I should get a 4, and that will tell me what the a should be. All right, so let's try this right now. So f of negative 2 is a times negative 2 plus 1. And we have negative 2 minus 2. Negative 2 minus 3, that has to equal 4. So a times negative 1 times negative 4 times negative 5 has to equal 4. So a times negative 1 times negative 4 times negative 5 is 20. So 20a is equal to 4. And then divide by 20. So a is actually 4 over 20 or 1 over 5. All right, so that means that f of x is then 1 over 5 times x plus 1, x minus 2, x minus 3. Now I'll multiply this out, so 1/5 times x squared minus 2x plus x minus 2 times x minus 3. Then combine like terms, so 1/5 times x squared minus x minus 2 times x minus 3. Then multiply here, so 1/5 times x to the third. Let's see, x to the third minus 3x squared minus x squared plus 3x minus 2x plus 6. Combine like terms, so we have 1/5 times x to the third minus 4x squared plus x plus 6. Then I'll distribute the 1/5 to get 1/5 x to the third minus 4/5 x squared plus 1/5 x plus 6/5. So there is the degree 3 polynomial meeting the conditions that it has zeros of negative 1, 2, and 3, and f of negative 2 is 4. So what a time to be alive. That's all the examples that we have for this section, and I hope that you enjoyed this video and that you're already looking forward to the next one. Thank you and have a great day.